Exercise 2.3a, question 7. Using the graph of y equals x divided by x plus 1 times x minus 2, shown below, sketch y squared equals the same thing. Okay, so key points to watch out for. Where does y equals 1 on our y graph? Where does it equal 0? Because we know we're going through those points there. Same over here. Anything negative we can ignore, so we don't need to worry about anything to the left of the x equals negative 1 asymptote, or between 0 and x equals 2, because all of those are negative values. And then we observe that for y greater than 1 on the y graph, we have the y values on the y squared graph are less than those y values. But they still have the same vertical asymptote at x equals 2, which means we're going to have this shape here. It's going to be, the y values are going to be slightly less for the y squared curve. That is until we get to the point where y equals 1 on the original graph, and that's for the output values between 0 and 1, the y values on our y squared curve are going to be slightly bigger. And so we get this kind of shape here. And it's still going to tend towards the same horizontal asymptote y equals 0. And the same situation over here. The y values are going to be less in the y squared graph than the ones in the original graph, when those ones are bigger than 1. But between 0 and 1, the y values in the y squared graph are going to be bigger. And not only that, the gradient at 0 is bigger than 0, we can see. And so that means we're gonna have this effect here. We're going to be curving around so that our tangent line at the point 0, 0 is the y-axis. Alright, and then that's all we need to do for that part. All that's left is just to reflect it. And that's very simple. So like that. And then like this. Well, hopefully a bit better than that. This is harder than it looks. I got a shaky hand, so it's hard to... that'll have to do. You get the idea. And there's what it looks like according to Desmos. So, close enough.